Time appropriate greetings for whenever this video finds you. Welcome back to our mini series exploring the RHEL 10 beta. I'm your host, Matt, and in the booth is producer Scott. This episode, our very special guest, all the way from the terminal, Nate Lager. Nate, for the very few people who don't know you, who are you, what do you do, and what do you do for fun?
Hi, I'm Nate. Another TMM for the RHEL team. If you don't watch Into the Terminal, you should, and then you'll know who I am. So, yeah.
That's fair enough. Fair enough. Before we get started, as we do every episode, release note of the week. This time it is brought to you by me and a random discussion I had with Nate on the nature of quadlets and containers and pods. So a little bit of a different episode today. We're actually going to do a live coding deep dive on some of the changes around pods and quadlets in Podman 5 and RHEL 10. But first off, let's start with the TLDR of that conversation, Nate. You said, if I can paraphrase, that you put all of your containers in pods all the time.
Yeah.
Why is that?
I do. Well, I guess I'll give you the short story. I used to be a Docker user, and when Podman came about, I just started to get right onto the Podman train. But all my Docker stuff was defined in Docker Compose. And at the time, Podman Compose didn't exist, or at least it wasn't ready for prime time. And you couldn't use Docker Compose with Podman because we didn't have that API, which, by the way, both of those things are now true. So if you're using Docker Compose, you can theoretically still use it with Podman. But after I switch, I rarely switch back unless there's a really good reason. So what I did was I switched over to Podman pods. Okay. The reason I did that is because you can export them to like a Kubernetes style YAML, which we're going to talk all about this as we get through the episode. And then it gives you a file that you can save and back up and restore and whatever, like you could with Docker Compose. So really, like that's the genesis of why I do it this way. I also think it helps to organize your pods better, organize your containers, I should say, better. It makes me feel like they're more organized, I guess is the way to do it, more contained, right? And if you ever need to add a supporting service, you just add it to the pod and there you go.
Okay. Well, that's a little bit of foreshadowing of what we're actually going to do later. But I mean, I got to admit, like, even though it's right there in the name Podman, and like I was there when the Deep Magic was written. I don't think I'm alone. I've never actually created a pod. I create containers. I use Quadlets. We'll talk about Quadlets later because we're going to talk about how to run these as services, and that's how we do that in the Podman world these days. So let's start though from the top. Like, why don't we do this? Can you describe to me like what is an actual, like, what is a pod? What does that do that is different than just a standard sort of bare container in Podman?
So a pod, and I guess actually, if we can just bring up my whiteboard, I can just go ahead and show you a diagram of what, like the way I conceptualize what a pod looks like. Okay. So whiteboarding is fun. So forgive my terrible handwriting, but like normally when you make a container, right? Let's assume that this line here is the network stack of your container host, right? Mm-hmm. Your container kind of hangs like right off of the network stack, right? Sure. You tell it what ports to forward or what ports to open, I should say, and then the host networking will get that port into your container. When you're doing a pod, and let me see here, I don't remember how to change colors. This should be easy. There it is. When you're doing a pod, right? So you still have that network for your host, right? Let's just say this is the host network. When you do a pod, you end up with more like your pod is like a shell around the outside of your container. And then inside of there, you can have several containers, right? Let's just say there's 5 containers in there. And then at the pod level, you say this port and that port come through the pod, right? And those are attached to your TCP stack on the host in the same way that a container would have. But now, like, say this goes to the port that opens on one container and this goes to a port that opens on a different container, or maybe they go to the same container. All these other containers that are in here, they're accessible within the pod to each other, but they're not accessible from outside, right? Which to me makes it, say this is my database, right? And say this is like a message queue, right? Those are things that outside of my container maybe don't need to be accessible. Now I've essentially got like another layer of defense almost in between my application, its supporting services, and the outside world. So that's why I like them. And there's sort of a namespace that goes on in here. There's DNS resolution. You can call containers by name within the pod, and it feels like it's a much better way to run services, especially services that have supporting services, than it is to just run containers side by side and map between them.
Okay. All right, so let me repeat that back to make sure I actually understand it. And hopefully I will answer Imran's question in that same process. So if I'm understanding correctly, like when we create a container, every container gets its own specific namespace, right? So you spin up a container, Podman goes, okay, namespace, you get isolated, you get your own view of the network, C groups, IPC, all that kind of good stuff, right? Doesn't see anything else on the host, can't do anything unless you actually start exposing things through host networking, for example, like you said.
Right.
Here, when you create a pod, that is a thing we put containers in, and that is a shared namespace. So all of the containers inside the pod will be on the same network namespace, so they can just talk to each other, but they don't, unless we make it, again, explicit choices, we can't get to them from the host. So they've got common IPC, common C groups. You can control all of their resources together as a unit.
Right. Okay. And you can start and stop the whole thing as a stack instead of individual containers, right? So you just do a Podman pod command instead of a Podman container command. So like Podman start and then the name of the pod, Podman stop, the name of the pod, and it'll shut down all the services within. Now, the one drawback I've run into is that I have not found a way to tell it which containers have to start first, right? So maybe you want your database to start first so that when your application comes up, it doesn't get a database connection error and die. There's a couple applications that do that, and sometimes it gets weird with a pod. I haven't found a way to fix that. If there's a way to fix that, I'd love to know about it.
there might be a way to fix that with Podman 5.0, which we'll see if that works or not. And well, if I read the man page correctly, because that's always, completely
that's always fun.
Yeah. All right. So let's do one more thing. Scott, if you could bring up my terminal, I want to try to actually make one of these things hand jammed. So I have here a Rel 10 beta system that has, double check here, but it should be Podman 522. Yep. So we've got all the right bits that we need in order to do what we're going to do later and what we're going to do today. But all right, I want to create a pod. I actually want to create a pod. I've got a MySQL. For what we're doing later, I've got some images here. I want to create a MySQL instance because we're going to use it later. But what I want to do, and this is a little weird, so bear with me, Nate. I want to do what you said, and I want to isolate it. So I don't want it to be able to connect to the host. I want to be able to just have this thing running and then have it connect from inside the pod, right? So what do I need to do first? It's Podman pod. I know that much, right? We get stuff.
There's a create in there, right? There's a subcommand for create.
Yeah, right up top. Create new empty pod. Okay.
Yep. And then you have to name it in the same way that you would name a container. So you do -- name and then the pod name.
So we're going to call it MySQL test. All right. And
then if you hit enter, that'll make the pod.
Okay. So this will create an empty pod.
Right. But we haven't told it to map any ports in. So if that's your intention, then we're right on track.
Yes. But I want that isolated database experience. So like if this were an application, which we'll connect to it later, the only thing we want to expose, right, is the app ports, not necessarily the database ports, right?
So that's one of the things you got to think about when you're making the pod, right? The app and the database are all going to live inside of the same pod.
Sure.
So you wouldn't forward the database ports at the pod level, but you would forward your application ports. So if it's a web application, 8443 or maybe just 80, you'd want to map that in when you're building the pod to start with.
Okay, cool. Good to know. So there's a -- port option we could give it to say, hey, needed.
It's exactly the same syntax as what you would do to map it into a container, which is just -p, and then the port number : and the port to forward it to.
Cool. Which, for those who don't know, that actually stands for publish, not port, even though they both start with P. All right, so we've got a question on resources with pods. Nate, you want to handle that one?
So if you have a pod with multiple containers in it, like you drew there, how much do you need to allocate for resources? Is it a lot generally? So that would depend on what you're running, right? It's really, I don't know that putting it in a pod changes the resource requirements at all, right? It just adds this extra layer of containerization outside of the containers. So if you're running a very lightweight application within the pod, then you will need lightweight resources. If you're running very heavy applications within the pod, you will need heavy resources. I know that's kind of a softball answer, but it really depends on what you're running in there. So if you're planning out, a huge database container, whether it's in a pod or not, you have to plan resources accordingly.
Right. But in this case, so if I were to run this, so we're going to run Forgio later, so we'll just put that out there. If I were to run that as a standard, the way I normally build Quadlets today, which would just be separate containers exposed separately, if I wanted to control resources, I would have to do that individually and sort of do the mental math of, I want to give the database X and the application Y and set up C groups and controls for each container.
Right. Yeah,
but this way I can just say, here's resources for the application, which includes the database, it includes the app server, and they can fight it out amongst themselves without having to be quite as granular ahead of time and fiddle back and forth.
If you're not constraining them, then it would just manage it in the same way that Podman manages containers, period, right? It's just that now it's inside of a pod. I don't think you can set restraints at the pod level. Maybe you can. I've never tried to.
Got it. So maybe they're not. We're not talking about C groups at this level, but just namespaces. Okay.
So cool. I mean, the pod is its own container, and if you did a Podman PS-A right now, you'll see an infrastructure container.
Okay.
Right. So you'll add this extra container, which then your containers run in. Now, I don't know it all the way down to the engineering level, so maybe we could have an engineer on sometime in the future to explain exactly how you put a container inside of a container. But I'd imagine that's something like a C group or a namespace that is being used to containerize the containers, right? So maybe you can put constraints there. I'm not sure.
Yeah. All right. Something to go back and look at, see how the other things like C groups interact with these shared namespaces. All right. So we have a pod, but we don't have anything in it yet. So how do we add the first container that is not this pause container that we actually want to put in? How do we get something in it to use it?
There is another quick question about resources here. Does putting containers in a pod add much in the way of resources? And I think the answer is no. I'd imagine there's some minimal overhead, but I don't think it's anything that's going to be significant. If you're running on a really tiny host, maybe you'll notice it. But I mean, I've used these, like I said, for everything that I run, and I've never noticed any downside. All right, so putting a container in a pod, basically you run the container the same way you always would have. So you take the exact same run command that you would have run, except you don't have to tell it what ports to forward because that happens at the pod level. And you add another argument that says --pod equals, and then the name of the pod you want to put it in. So if I did like a podman run --pod equals, and then what'd you call this? MySQL test. And then the rest of the command line is basically identical to what you would normally do, right? So,
all right. So we're going to go ahead and we're going to attach that. And what I need to do, let's go back up here and get our container name. I'm trying to think if I just run this bare, if this will actually start MySQL, and if I have to create a whole bunch of users. All I really want to do is just sort of show proof of life and connect that it started. So I don't think I need to create a database. I think I can just go ahead and run that. And then I guess we'll go ahead and we should probably give it a name too, right?
Yep. Obviously, you don't have to. It'll give it a name for you, but they're always hard
want
to
make sure.
Yeah.
All right, and I think that should be sufficient to get this thing to run. Except I got to do that in the right order, otherwise that's going to try to pass that as an argument, which is not what I want to do. Live coding, fun stuff. Cool. And it failed because clearly I needed to give it some extra mojo. So let me go.
Yeah, you probably need to give it at least a root password. So you'd set an environment variable for, what is it, all caps. Is this MySQL or Maria? MySQL. So it'd be MySQL underscore root underscore password.
Yeah, I'm going to cheat and go to...
Cheater.
And where is... we're just going to go ahead and search for the rel 9 because I know for a fact, because I've done this before, we have an example that works in the catalog on the MySQL page for the container.
There you go.
So I can look for MySQL, and it is MySQL standalone 8. This is the rel 8 version, but that should still be fine. All right, so I need to give it, just, we'll just grab these parts. And we don't want to expose any ports. So copy and pasting. All right. All right, so we have our new name. We have user password and database. It's going to auto-create. We do need to go back in and make sure that we stuff it in the pod, right, and not run it on its own. And we're running the one I have downloaded, not trying to pull something new.
Sorry, I'm trying to get my next share ready, and it stole your share, I think.
It's all good.
Just show me.
It's I'm seeing your VS Code, but in the meantime, I now have several containers.
Just when you think you know how the tool's going to work.
Of course.
Yeah.
But all right, we now have a running MySQL instance inside of our pod. We also have the one that exited because I did it wrong. So we now have multiple containers. And if I go ahead and look for really anything, we don't have any ports, right? I've got Cockpit running on this thing, and you can SSH to it, and that's about it. So if I were then to want to connect to this, what I can do is I can actually run we're going to run a client instance.
Yep. That's the way to get it done. Put it inside the pod, and then within the pod, you'll be able to get to it.
Now, I'm going to use localhost, and this is because the actual IP address. This is because of something I know from dealing with MySQL for a long time, is if you tell it localhost, in fact, let's just...
It treats it differently. Yeah.
It does. It treats it... It doesn't treat it as a host name. It actually... Oh, you know what I forgot to do?
You have to do -it.
I wanted...
You can't run it in the background, Matt.
I ran it as a daemon. I wanted to run it interactively.
That's going to tell you the container exists.
I need to replace it because...
You could delete the... You could remove the other one if you want to.
Oh, we're going to run it a few times, so I'll just tell it to replace.
Oh, there you go. Replace. I forgot about that.
And what did we set our super secret password to? I believe
pass, wasn't it?
It was, yes, super secret AAS. And no. So yeah. So if you tell it localhost, and this is a weirdness of the MySQL client, is it tries to use the local socket, not use that as a host name. So first off, we need to go ahead and let's just do this through the network stack as localhost IP address.
Now, I want folks watching to realize what's going on here, right? So Matt has the MySQL container running within the pod, and now he's started a second container running the client, right? So why on earth should I be able to reach it over localhost? That's because it uses that shared networking within the pod, right? So you don't have to call it by the name of the other container, but you also could.
Right.
Are you still having trouble connecting?
I think I just fat fingered the password. So what you said though, I can use the name of the container as the host. So
you should be able to.
If I grab MySQL database, which is the one that is actually working, and we do that again. All right. Well, probably something with the example that I grabbed that isn't actually setting up the password correctly. That's what I get for copy pasting. But it actually tells us we are using the network to try to connect on localhost, even though we used the container name.
Here's some fun things we can do with the pod. Now, I can't see your command line. Are you still in the container or are you at your host?
I am at the actual host.
Okay. So if you do a Podman pod logs. So Podman space pod space logs, and then the name of your pod. This is actually another thing that I like. It'll show you the logs from all of the running containers.
All right.
Within that pod, right?
Log MySQL-test. Whoa.
Right.
Yep.
And so the reason I like this is because if you've got a bunch of, you've got the web application and the database and other supporting services, and you're like, something's not working and I don't know what. Pod logs will give you the output that's coming from all of the containers, right?
Nice.
And then that ID at the beginning of the line is which container it came from, which of course you'd have to map back to which container is which. But
cool. Yeah. So this is showing all of our various different containers and all the initialization from setup. Okay.
So theoretically, you could scroll through here and try to find the spot where it initialized the database and see if something went wrong, and that's why that password's not working. But I wanted to show that just basically as an example of one of the things you can do with a pod instead of just an individual container. And there was actually a question regarding this, so I thought maybe we would show it quick. You can also stop, start, and restart the whole pod using Podman pod stop, Podman pod start, and Podman stop restart, right?
All right.
It really rarely shuts down in a pod. Does it do a heartbeat to restart it? So the actual question around this is, if a container randomly shuts down in a pod, does it do a heartbeat to restart it? And the answer is not by default, right? There are health check commands that you can build into your pod, and not just your pod, but your container, so that it will check to see, is it up and healthy? And then I think you can tell it to do things like restarts if a container within your pod goes down.
So we still have access to the same sorts of things that we have for individual containers.
Yeah.
Inside the pod.
Yeah. Anything you can do with a container outside of a pod. Maybe I shouldn't say anything because I'm sure there's something that's different, but most things like health checks and stops and restarts and whatever, like those are all things that you can do inside of a pod as well. In fact, you can start and stop individual containers in the pod too, right? You just don't call the pod, you call the container, right?
So we've stopped it. It shows us it's exited. It shows us we've got 4 containers. I also pulled up a new command completely by accident. Apparently Podman pod also has a PS that shows you just what's going on at the pod level, whereas before we were looking at it at the broad container Podman PS level.
And that's another useful thing. After you start this, if I remember correctly, you have 2 MySQL containers in there, one of which won't start. If you do a Podman pod PS now, the status will show degraded because it knows there's supposed to be 3 application containers running in there, and only 2 of them are running, right? The 4th one that says number of containers, the number 4 is that infrastructure pod we saw earlier, infrastructure container. So there you go.
And that shows our exited, and that's so this is the way that you can see that we can still use health checks and all the rest. Okay.
I do things on my Podman host, like write a shell script that'll do a Podman pod PS and look for any pods that are listed as degraded, right? And then if it finds one that's degraded, I can then take action on that, like restart the pod or try to figure out which container is down and start it directly, or send an alert, whatever it is that I want to do with that container that's degraded. So just things to keep in mind. And there may be more intelligent ways to do that than just a bash script, but I'm an old sysadmin that likes to write things in bash, so that's what I did.
Sounds good. All right, so we're about halfway through the hour. So if you're
we barely scratched the surface.
Like, subscribe. We'll get into more detail on this after this. But ring the notification bell to hear our last few episodes upcoming on our beta mini series. We took our break. We're back. We're going to be back next week. Now, okay, so we got through the pod part. I get this now. I think I know what I'm going. Quadlets I get. Quadlets I work with all the time, right? So for those who haven't seen Quadlets yet, these are basically config files, right? They are systemd flavored config files that allow us to generate systemd services automatically for containers, right? And I've actually, to save more copy pastaing, I've actually grabbed the ones that we'll be working on later. So we can do things like containers, you can define networks, you can define volumes, all the things that you would normally do around a container. And in this case, in a pod, you define these in sort of systemd typical formats. I'm going to show the Forjo one, unless you've got something else, Nate, that you wanted to walk through. So it looks very much like a standard systemd unit file, right? Apparently, we can even do drop-ins to override stuff like you would if you get the naming right. For 5.0, they added templates. I don't really know why you would want templated Quadlets, but hey, if that fits your use case and you're good with systemd templates and you want to run,
because everybody likes templates,
random 47 different kinds of the same but slightly different Quadlet, you can do that now in a fully manner.
I do that, right? And we'll there's one other topic I think we should cover before we switch to my screen share, and that's the YAML that I was talking about. And I can also go over my Quadlet once we get there. But when I define Quadlets, they all do look very similar. There's differences like what file I'm calling and what ports I'm opening in the Quadlet. So I might be able to leverage a template for that. I'd have to look into it.
Yeah, so you mentioned, so this is all systemd native stuff, and that's something else we're going to look at later. But you mentioned using the kubeyaml really early on. So like, how do we get from what we've got running now to the kubeyaml?
This is one of the things that kept me on pods after the Docker Compose stuff started to work with the I don't want to say emulated, but the API that was been implemented in Podman that'll let you use Docker Compose, right? Kubernetes. Have you heard of Kubernetes, Matt? You know what Kubernetes is?
Yeah, I think so. It's that it's that thing that everyone runs their blogs on, right? You spend 47 servers in order to run a Ghost template. Is that's what it's for, right?
Right. So anyone who's not familiar with Kubernetes, I mean, I'd be surprised if you're not, if you've been in the container space at all. But Kubernetes is like a larger, more, I don't want to say enterprise grade, but clusterable, perhaps, container management platform. And it's the thing that OpenShift is based on, right? So OpenShift, of course, would be like an enterprise grade Kubernetes with a nice UI and all that stuff. But it uses YAML to define just about everything. And one of those things is pods. Recognize that name? So when I was looking into Podman and pods, I came across this concept of these YAMLs that will go into Kubernetes. And I thought, hey, someday I might put my stuff on Kubernetes. So it makes sense to have something that might be transferable to Kubernetes, and Podman makes that easy. So on your terminal here, if you type Podman generate kube, K-U-B-E, space, and then the name of your pod. So MySQL-test.
Just the name there?
Just the name. And hit enter. It'll spit out on the screen YAML. And this is basically a definition for your pod, right? This tells it what images it's running. If you had opened any ports, it'll tell you what ports you had passed in. Any environment variables that you set, you can see them right there under env. And this, I won't say is 100% of what you would need to run this pod on Kubernetes, because Kubernetes has some stuff that Podman doesn't, right? Because it's a more complicated deployment. So there's things you have to accommodate for, add-ins and whatnot, like how am I handling storage and stuff like that. But you can take this as a base and bring it into Kubernetes and deploy your pod there, which I think is really cool to be able to go from a single host containerization platform like Podman and bring it into Kubernetes, right? So that's why I define them all this way.
Okay. So you dump these out for what you do, and then
yeah,
you said you'd be able to make use of the template. So you have a Quadlet example that you've
so if we want to switch to my screen share that I accidentally overrode your share with earlier. So this is VS Code if you're not familiar with the output here, but this is an example of a WordPress deployment using these YAML definitions. And is that big enough for folks? Let me make it just a little bit bigger. And now it's like off the edge of the screen. It's almost like I've never done this before. Okay, so you can see at the top here, it tells you that this is a pod. It applies some metadata. That metadata is the name of the pod. So this thing where it says app and name, that's if I were to deploy this in Podman, the pod would come out named WordPress. So obviously, if you're running more than one, you'd want to change this to something other than just WordPress, but you get the idea. And then this section that says spec, this is the specification for the pod, right? And inside of here, we have a block for containers, and you can see I've got a database. And then I have this thing that says, instead of env, like we saw in yours, and then it called out all of the environment variables, I have this thing that says env from, and I'll explain what that's about in a minute. Or I should say, I'll show you what it's about in a minute. I use these things called config maps, which is another Kubernetes sort of way of defining stuff. Podman supports it too. I have this separate file over here that's called WordPress config map. And inside of there is all my environment variables, right? So things like the passwords for my MariaDB deployment, I use Mari instead of MySQL. The WordPress configuration, and you can extend this further if you have, an application that uses more environment variables. For whatever reason, this is the accepted way to pass configuration into containers. If you're wondering why I'm putting things like my MariaDB root password in an environment variable, that's just kind of the way it works in a container. Now, you can use things like Podman secrets to mask these things. I haven't gone that far with that because, well, I guess I just haven't learned enough about Podman secrets yet. So that could be another thing to delve into. But then this basically tells it, take that whole environment from the config map and pass it into this container, right? So the database container gets all those environment variables. If I were to go to this container and look at the env, it'll show up all those things. And then, of course, what image to run. I'm using the MariaDB UBI from Docker Hub. And, all the things that you configure. The other thing I wanted to mention was these mount paths. This is if you're passing in volumes for persistent storage, which, of course, you would for a database. You would for WordPress, right? And those are all defined right in here as well. If I go all the way to the bottom, you can see down here, here's my actual volumes and where they map to on the container host, right? So these are just simple volumes that I've passed in. You can do stuff like NFS volumes, but those would have to be defined outside of this pod definition, right? And that's where things get a little more complicated. And then the last thing I wanted to show you was, how do I turn this into a Quadlet, right? Because my pod is now defined in this file. How do I get systemd to start that as a pod? Now, there is a definition for Quadlet that will define a pod, and then you can put containers in it. I like to do it this way, and I haven't run into a reason why I shouldn't yet. Maybe someday I will. There's this .kube type that you can put in, and you can just point it at the YAML. So now whenever I go to define a new, say I'm defining a bunch of WordPress instances, I just take this file and I put it, I put the YAML for the pod somewhere that's accessible. And then the config map as well. I have to tell it also use my config map and point that to where it is. Otherwise, Podman doesn't know where my environment variables are. What port to publish. And then what this will spit out is a systemd unit file that'll start the whole pod at once. And the really cool thing that I like about this is if I stop the pod and start it back up again or restart the pod, it actually destroys the pod and recreates it. When it recreates it, it pulls down the latest definitions of all of the containers from the registry that it came from. So it's a thing you want to be aware of, right? If you don't want it to do that, then you have to tag your containers so they're using the specific version that you want, and it won't just get the latest version. But if you do want it to update in an automated fashion like that, all you do is restart the pod. You restart it through systemd, and then it'll pull in the latest versions of these containers. If you need to change the configuration, you just change it in this YAML file and then restart the pod, and then it destroys it and brings it back up with the new definition. I think it's a really sleek way to manage your pods. So, my opinion.
Well, you're entitled to your opinion.
I am entitled to my opinion.
But I'd like to take your opinion and use that as a launching pad for something that is new in Podman 5.
Okay.
Because, this is good, right? But there's either you have to know kubeYAML and have a template already to like get into how you would define it from scratch, or you have to do it manually.
Yeah. I'll usually take most projects come with a Docker Compose file. I'll take the Docker Compose file and read it myself and create a pod based on what they put in the Docker Compose, which isn't always directly translatable. You have to make some guesstimates. And then once the pod's created, I'll export it using that generate file, that we just talked about.
Cool. So we're going to do that, actually. And if we can switch to my screen share, there's a new thing. It is a new type of dot file, right? We've talked about containers. We've talked about the dot cubes. We have a brand new thing for Podman 5 called dot pods.
There you go.
Which means we can actually create these from scratch, define them in a Quadlet format, right? Systemd style, and then just modify our containers and our volumes just a little bit, and then run the whole pod from scratch as a Quadlet. So rather than go through what we did the first time around, so I've been playing through image mode and some other things with like CI/CD, Git Forge stuff. And I wanted to do something local, and like that's kind of difficult with GitLab and some of the other things, but I played around with a few things and then noticed that the Fedora project selected Forgeo as their new Forge. So I took a look at that, and it turns out that in their documentation, they provide not only a working Quadlet that you could just copy and paste out of their documentation and work, which I have done. So you don't have to watch me copy and paste again. But they also do provide, if I scroll back to it, a Docker Compose file with a MySQL set of configuration in it, right? So I think what I want to do for the rest of the live portion of today, you can help me make sure I get all this stuff straight. What I want to do is I want to start with what we've got from Forgeo, and then create a container file for MySQL, and then take out the important bits of this compose file and put it into the new .pod format and see if we can get this up and running in the next 15 minutes.
Nothing like having a shot clock, right?
Exactly. But hey, this is all...
I'm sure it'll be fine. What could go wrong?
What can go wrong? It should be all fairly straightforward, right? So, first things first, I want to take a look here because, so the things that we're going to use, right, we're going to need to define a network here because the Forgeo example has one. We're going to have to name it something based on your explanation earlier. DNS and things, like we're not using any alternate DNS, but I guess we could if we need to. And then of course we're gonna publish some ports, and that's really about it. Volumes, we're going to actually use the volume and map those in another way, I think. So we'll come back to that one. That might be the tricky part of how do we get volumes in there. If we do it in a volume file and add the pod, or vice versa. So I think what we'll need for a pod definition should be fairly straightforward. Everything else we can just should be, you do it the same way, and then you just add this new pod equals with that pod name, and it should all just, the system generator for Quadlet should just string it all together and do all the right stuff. So
right.
Enough of the things that we know work. Let's get into things that we have no idea whether or not they work at all. Cool.
I have faith in you, man.
Yes. Why succeed when you could fail on live stream and make people laugh?
Yeah.
So, all right. So like I said, I did grab the Forgeo container, network, and data volume. These are just copy and pasted. We saw them earlier from the thing. The MySQL ones, like those, I just created them so I don't have to mistype those on live stream. I try to give myself as little room for typos as possible. So the first thing we're going to need to do, though, is let's create a Forgeo. See, already typos. We're going to have a pod file, right? And in that pod file, we just need to start giving it arguments, I think. So that, whoops, the first one was pod name, and we're just going to call that very uniquely Forgeo, because I like saying that because it's Esperanto and I don't get to use Esperanto enough in real life. We wanted to go ahead and publish a port, but I don't know what that is because we need to go back to the documentation. So
we can make one up if you want.
Pardon?
We could make up a port if you want.
We could, but it would be hard to get to the actual app. So here are the published ports. So actually, this is the same. See, this is the nice thing about using documentation, or having somebody who works with these formats. They're the exact same argument format.
Yeah, you may need an opening bracket or opening block in your.
I think you're right.
That says like pod, maybe. I
think
don't know
we're
what
gonna need to do
like
that.
The first line should be like square bracket pod.
I agree. All right.
The docs would tell you if that's the right format or not, but I think that
probably.
Would be,
I am sure.
Judging from what other ones, like the Kube one uses bracket cube bracket, right?
Exactly. And that should be up there. You go. Supported keys in the pod section. I didn't have to go all the way to the bottom to see what the example says because it's right there. I should have had a section. Right. So as far as I can tell, that's all we needed to do to actually have systemd generate a quad. So let's go ahead and pod.
Can you define the containers within here too, or does that have to be separate files?
So this is the other way around. So once you define the pod, it's sort of like the way that you define networks, right? So if we cat Forgeo network file, what happens here is we define a network and we just call it Forgeo. So that means it'll automatically create that. It really doesn't do much since we're not adding any new configurations. It just names that new network namespace in a particular way. But if we had DNS or other things we needed to do for the network, we could do that here. I think you may not even
need that if you're using the pod though. So
yeah,
this is one of those things where I'm saying, right, like if you're looking at a Docker Compose file, it's going to have you define networks, and then you have to translate that in your brain. Like, well, my pod doesn't really need a network. I don't even know what would happen if you put a network inside of a pod. Would it have like a layered network? I'm not sure.
I think what it does is it's going to create the same network namespace it would. It's just going to name it Forgeo as opposed to whatever random thing it decides to name that network.
Right.
So the way that we actually add a container to it is instead of telling it, we just go in here and we say pod equals Forgeo. And now this container is now automatically, once the systemd generator, because the systemd generator is going to take all of these things together at once and say, oh, I've got a pod, oh, I've got networks, oh, I've got volumes. And it's going to stitch all these things together and automatically create the pod. So this is how you associate these containers and other components that you would have for individual containers
with the pod
in a Quadlet. You bring them together in the pod that way, as far as I know. We'll see if this works.
I guess we'll see at the end.
We'll see at the end, because I'm going on having read the man page and vibes. So we're gonna work this out as we go. So
it makes sense the way you describe it. So we'll see. Sometimes computers don't make sense. It all depends on how good of a day the engineer was having when he wrote it.
Exactly. So we've got our basic pod defined, we think, and we've added the Forgeo container as the example. So now we need to go back through and go back to your to that Docker Compose, and we do need to completely figure out how we need to build the MySQL container and the data volume that it wants. So let's go back and find our Compose. Oh, we also have a bunch of new variables that we're going to need to add to the Forgeo container I'm seeing here, so that it actually uses the database, which makes complete sense. But here is the new thing. Wow, this is actually really simple.
Pretty simple.
It's just an image and 3 environment variables. Cool.
Four environment variables.
Yes, that's what I said. 5 environment variables.
5 is right out.
Yes. So we're just going to go ahead and copy this. And I'm going to scroll up so I have an example of what I'm doing. And we're going to go back over to, not that, we're going to go to my terminal.
The terminal, right?
And so we now have our, I've already hit insert. So this is our container. And so we have our container section. And I'm just going to go ahead and dump our things in here. And so I need an image, and that is wrong, but I'm going to take a good stab at what I think it is, and we'll go back and fix that in a minute, because I know that is not probably correct. All right, and then I need to go ahead and set up the environments. And this is just environment equals and then equals.
So for folks that are watching that might be wondering why the image has changed from something simple like MySQL 8 to registry.redhat.io/rel9/MySQL-80, it's because Podman doesn't make assumptions about where you're pulling your images from, where Docker, which is what most people write these Docker composes for, does. Docker will assume you're going to docker.io unless you've told it otherwise. So if you don't specify what registry, which is what the registry.redhat.io/ is all about, then when you try to start your container, Podman will come up and say, wait, where do you want to get this from? And then you'll have to pick one. I don't know what that'll do with the systemd unit file. If it'll just not start, if it'll make a guess, I'm not sure. But it's always best practice to define the full registry URL, which is what Matt did here at the top.
Yes, I also went ahead and pre-pulled these. These are also local, so that we're not waiting on whether or not my internet connection decides to play with good today.
Like you planned ahead.
Oh, just a little bit.
Me, I just rolled up to this.
So we should be good here. So
yep, drop all those.
I'm just going to go ahead and drop all that, and that should be everything we need.
But we need the volume.
That's not what I wanted to do. I want to. We got to make sure we're using pods. So we're going to tell it.
Yep.
We want this in the Forgeo pod. All right. So that should and this is where we're gonna wing it with, specifically with the MySQL container. Normally, you would go ahead and not only create the volume the volume file that we're about to make, but you'd also still define it here in the container, right? Because you still have to make those connections in the Quadlet files. I believe.
Yeah, there must be some way.
We can centralize all of this, the network, the volumes, and all that, by putting them in the pod, as opposed to the individual, like make sure they're all connected file to file. So that's what I'm going to experiment with here, and see if that burns me.
Normally, what I would do is I'd make a .volume Quadlet and define my volume in there. And then in the container is where you would say, use this volume for this storage, right? Unless you're doing local host paths, in which case I wouldn't do that at all. I would just put it in that YAML file. I have no idea how you do that in the Quadlet because I've never done it that way.
So we're going to figure that out live. So volume, I already forgot what that volume was supposed to be. Let's go back to our Docker Compose.
Probably the Maria
something
or
very
MySQL
simple.
data.
Yep.
Like varlib MySQL.
And our example. All right, so this is the data volume that they're using. So it's just volume name and then the name. Because it's all fairly straightforward. Because they're doing an automatic one.
Where do they? Here, are they just letting Podman make a volume?
They are.
Okay.
I'm going to go back to our docs.
How do we make a volume?
And that was the wrong search.
We need a Quadlet volume.
Go back. And now, Control F for volume. And that is going to be terrible. Excellent. So I'm going to do some terrible scrolling.
Is this just definitions for all the different types of Quadlets?
It is, yeah. This is, so the Quadlet man page has all of the different options for all of the various different.
We don't know how to sort these out yet, so just put them all on the same page. We'll come back to it later.
Exactly. And I need the one that is all the way at the bottom because they are in alphabetical order, I think.
Well, at least they have them in alphabetical order.
And there we go.
The volume, look at all for all the yellow. Okay, so let's see.
So where do I specify?
So we need a path. The type you're using is a host path. And like I said, I don't know. I've never done that type of volume in a separate .volume definition.
Device.
You think you would use device, but device, if I remember correctly, is going to give you an error if you point it to something that is not a block device.
File system, the type defined by the mount commands. Yes. Volume name.
Yeah.
All right.
Can you, in the .container Quadlet file, how do you define a host path in there? Because I think that's what you need.
Yeah, so that one actually just uses, let me drop that in there so I don't lose the path that we actually want. So this one is just, so this is doing it this way.
Yeah, that's calling the volume. So if you successfully define a volume called Forgeo data,
right,
or Forgeo, however you're pronouncing that, then that'll call that volume. Now the question is, how do we define the volume so it calls the host path? And I've always done host paths within the container definition, not within a separate volume. Because every time I've tried to do it, it's always been like, well, no, you have to use a block device for a .volume.
So we can do that, right? Because if we're gonna, so there's two options here. One, we could cheat and do the same thing that the Forgeo folks do, which is let Podman auto create a volume and let it handle all the things and just name it appropriately.
Right.
But I think I like your idea, so I'm going to go ahead and take this path, and Nate, you're going to show me how we create the host path in the container file.
Well, I do it in the YAML, right? So you may have to go back over to that docs page and go back to the container space, container namespace or whatever it's.
All right, and container, of course, is. So pardon our scrolling.
Way at the top. Yeah,
all the way back up to the top.
Scroll back to C. Pod.
Which I realize this is not in complete alphabetical order because they inserted pod before kube, which I guess makes sense because they're in like some sort of.
Okay, so here's
order.
container units.
All
is there a thing in here for something like host path or for path?
So let's check down here. We got mount types. We have volume, and this just says volume source dest.
Oh,
so this is the same volume definition that we were using before. So we can just
it looks like you would just use volume. You'd put the path at the beginning, the local path, and then the destination path at the end. So yes, we would use volume.
And Ben there in chat just solved our problem for us as well.
Thanks, Ben.
So the only thing is, this is actually backwards.
Well, it's not quite backwards.
Yeah, because we want source then destination, and this is actually this is
it's calling /MySQL as your source.
You're making up /MySQL. Yes.
Yeah, you change /MySQL to wherever you want this data volume to live.
All right, so there we go. So now we're going to do it this way, and this should auto define that. And I think then actually, so what we still need to do is we are actually going to need to recreate that volume I just destroyed and just call it we just need to have the volume name in there of MySQL so that way it gets created correctly.
No, I don't think you'd do that.
Yeah, because
what should happen in the
path. Okay.
So in the container definition, you're pointing to a local path, and you're mapping it to a path inside of the container. So it doesn't need an external volume. I think it still treats it like a volume. It makes like a volume in the background so that Podman can reference it that way. But you don't have to give it a name or anything.
Cool. I think we're good. As far as I know, to copy all this stuff into
as long as you set that path to something that exists. Is it just pointing at /MySQL there?
We're near the top of the hour. And we're near the top of the hour, and we're just going to go ahead and figure out what's going on. So what we're going to do, let's see. So these all live in Etsy systemd.
Nope. Oh. You do the same thing I did. It's Etsy containers systemd. I always get them backwards too.
Systemd. All right, and we need to do that as the appropriate permissions. And we give it our super fancy password.
Now there are ways to do these as a user, right? That's one of the powers of Podman, that you can run containers as a standard user. It's a lot easier to do it as root.
Well, I also want this as an official service on my host. This isn't just for me to be running. I'm actually going to be running a Forge locally, so I want to do
well, I think systemd will let you do unit files as a user and start them at boot. So you could still run it as a user. It's just that it takes a little more forethought than we've put into this particular episode.
All right, let's see what happens if we do a daemon reload and if it likes those or not. It did an error, so I think that's a good thing.
Okay, now you should have systemd unit files or units. It could be called Forgeo -pod.
Now, how do we... Forgeo service could not be found. This I didn't think about. It should just...
what does it
should just start.
So list units and grep for it.
Yep.
I don't know what the naming convention is. It might come up as a -pod.
Might not be. So it silently failed, I think.
So there is, I'd have to look up the syntax.
Generator failed with exit status 1. So we've got a very helpful error message in our logs.
Exit status 1. I mean, don't you know what that means?
Of course.
It means that it failed. So
now, the question is...
You can call, and I'd have to look up the syntax, and I don't have it handy. You can call Quadlet to generate it as a dry run and output the stuff. But it's like...
It's somewhere in user lib.
It's like user lib something 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 Quadlet -- dry run. Let's see if I can find it quick. User lib exec podman Quadlet -- dry run.
Dash in the middle. All right. Pod4geo is not Quadlet based. Pod4geo is not Quadlet based. Okay, so clearly I did something wrong. We have our pod service.
Terribly wrong.
And it published the ports and it wants those things. And it has source paths. So clearly I did something wrong with the association.
Does it?
Of the container. So it worked with our service. It worked with the volumes. It got to the pod, created the pod. But when it goes to the actual container to create that, that's where we're failing. So clearly I missed something in the docs here about how to use this association of pod.
Sure, it looks like you got it right. Are we going to have an episode 2 of this? Because we are. We're over now.
We might. Because we are over. Specify a Quadlet pod.unit to link the container to. Well, there you go.
Oh, it has to have a .pod.
It has to have .pod in it. All right. So let's try that one last.
Let's try that quick. See what happens.
Real quick. And we're just going to do the wrong thing.
Do it right there in Etsy.
Place.
So that you can overwrite it later on accident.
Exactly. And so this is supposed to be .pod. And we'll do the same thing real quick for MySQL. And then we'll just go ahead and run the dry run one more time. And there we go.
Looks better. Do another daemon reload. It's in the history somewhere. Find it. There you go.
Oh, that didn't work. And there it auto-completed. So that's a good sign. All right. It appears to be doing something.
Something.
Canceled.
Except it
canceled. So we got there. We're getting there. We're on the way.
We're getting there. It's a good start.
It's a good start, especially for something that I specifically did not prep for because I wanted to see how easy this was. And it's actually pretty easy, even though we didn't quite make it there today, Nate. I appreciate your help. I think for me anyway, I like the idea here of doing pods directly in Quadlets. I understand the use for the kubelet sort of route. Thank you for explaining pods to me. I now understand those better, and I think I will start using them more often in my own environments.
Yeah, I like them. I like the way they work.
I think this is good work. We might have to come back after next week, because next week we're going to be joined by Fedora Ambassador to talk about how he uses upstream projects to prep himself for things that eventually show up in the in RHEL 10. So he uses Fedora. Not only is he an ambassador, but he also uses it to stay abreast of changes he knows are coming. And we're going to talk to David about how he does that, how you can do that.
Yeah, absolutely. I do the same between Fedora and CentOS Stream, right? I mean, you've got everything you need to try to learn this stuff before it hits RHEL.
Exactly. So you can catch Nate every Friday. Is that right? For Into the Terminal?
Every Friday, except this Friday.
Except, of course, except this Friday. But hey,
but next Friday,
subscribe, ring the bell. You'll know whether or not Nate is going to be live on Friday.
Exactly.
Notifications.
Exactly.
So until then, on behalf of myself, producer Scott, special guest Nate, and everyone here on the Red Hat Enterprise Linux team, I thank you for joining us for this episode of Live Coding Failures with the RHEL 10 beta, and we will see you next time.
Like 95%.
95%. Close enough.
Thanks, everybody.
Cheers.